Hello there and welcome to the shop. So today we're going to tune this CNC router right in so it's very accurate, and I think the next video or maybe the video after we're going to be doing some cutting with this, and as you can see off camera over the last week actually I've got this painted and I've made the bed and put this on. It was exactly the same process as the last big build I did, so I didn't see much point in videoing it again. So it's exactly the same sort of design bed. Okay, very firm, 2 layers of 19 or 18 millimeter actually, 3/4 of an inch, MDF slotted. So I have these T-slot, T-nut bolts, whatever they are, T-bolts, and clamps which you can get off eBay. They're you know, a few bucks. It's you know, better than trying to make them. You know, I mean they're made in one piece. The actual T-bolt, they're not welded or anything, and they're good, fairly good quality if you know what they are. So I decided just to get some off eBay. So when you've got your CNC router moving, because that's all this was, it wasn't tuned in at all, I just set some parameters up in the last CNC video that I did, just to get it moving. It wasn't set up accurately at all. So it really starts with setting the drivers. So I'll show you what I set mine at, and we'll take it from there. Okay, so don't let these numbers confuse you. All right, this is just setting the dip switches. By the way, these are the dip switches. These little switches here. Now they're broken up into 3 sections. The first section here is, well, what ampage do you want to feed out to your motors? Now, as this is a new machine, I didn't want to sort of give it full ampage of you know, peak amps of 4.2 amps. I tend to be a little bit sort of conservative, and in my case I've set the first 3 dip switches here on, off. So on, off represents midway, which is 2.6 or 2.8 sorry amps peak and continuous of 2 amps, 2.03. So it's on, off. It's as simple as that. Now then, this is where a lot of people get a little bit confused. Now, switch number 4, okay, which is that one there, switch number 4, I've got in the off position. Okay, so it just means that switch number 4, off is half current, okay, when it's holding. That's what this means. So when you've got it in the off position, it means the holding current on the stepper motor is going to be half of the current that you've set here. That's all it means. Now, why I set it to half current to hold is because otherwise, if you set it to full current, your motors get really warm, or they can get really warm. So in an effort to keep things nice and cool, and you know, it really, it's only sort of holding the screw from allowing this to come down, and sort of holding it in one spot. I was talking about the Z then. And I have always found that the half current is absolutely fine. So that's what I've set it to. Now then, these stepper motors require 200 steps per 1 revolution. Now that's full steps, but you can, shall we say, get much more accurate if you use what is known as micro-stepping. Now this is micro-stepping. So 400 steps per revolution is like a 50% reduction then in steps. In other words, it takes twice as many steps of the motor, micro steps, to make 1 revolution. Well, I normally set mine to 1600 steps. I find that, you know, it's sort of midway. It always works well with all of my machines, so that's what I've set mine to. And that is, and actually, if you buy in a CNC router, that's normally what it's set at. So it's off, off, on, on. The last 4 switches, so it's off, off, on. Okay, so that's 1600 microsteps. So that's what I've set mine to, and everything appears to be absolutely fine. Okay, so we're going to move this cursor now down to machine, press open, move it all into motor set, and you'll see here that the manufacturer's recommendation for 320 is actually set for 1600 steps or 1600 microsteps. So, and you know, I've changed this now to coincide with 1600 steps. The velocity I've just dropped down a little bit because it was a little harsh, and I've also taken down the acceleration a little bit because it's a brand new machine. You know, I like to do things a little steady. So this is the setup that you probably should have, and so everything should be fine there, but we're going to check it out in real terms in just a moment. So this is set all okay. Exit that for a minute. Home in, that's all switched on. Exit that. Soft limits. Now then, I can't fill the soft limits in yet, and we will be doing that for this video, because I need to know that the axes are running absolutely true and accurate before I fill this in, because what is read in the DROs might not translate to physical movement on the machine. So that's what we're going to check now. Physical movement to what we set this at, or what we set in here to move. So we'll come out of that, and we'll fill that in a bit later, and we'll come out of that, and we'll go onto the machine now and do something a little bit more physical with it. I have noticed a couple of you send a couple of comments in, and one patron actually, saying that they set their SMC up and that when they start to do a job, the Z-axis does not come down to the desired height to start the job. Well, this process that I'm doing now in getting the steps per right and the amount of travel right in relation to what the DROs are saying, this is part of it. And why I haven't actually written back and told you how to put it right, it's a long process. And I don't know your exact problem, but I'm surmising it is this. Okay, so this is me answering the questions that are coming in. Okay, so I'm going to set up now just this piece of MDF on here and this 600mm rule, because the larger amount that you measure, over a distance, and sort of cross-reference it with what your DROs are saying, the more accurate you're going to get the machine to run. Okay, and it should eliminate any of those problems with any of the axes not actually going the full distance to what you require them to. So I'll set this up. Right, so let's put this on top of here. I'm going to run this now accurately over to there. So let's bring it down some. Over. I've got that point directly on there. I'll zoom you in slightly so you can maybe be able to see a little better. Okay, I'm set. I mean, the camera's looking at it from a bit of an angle, but believe you me, it's set right on the end there. So I'm going to zoom you back out. I'm going to take you back to the controller a second and show you how to set a specific amount for the router or a particular axis to run. Okay, so what you do with the SMC, there's this D with an arrow and a line. Okay, now you press that, it fetches up this window. Now scroll up to the open window there, press so it goes green. Now I want this to move 600mm. Okay, then press again so it goes yellow. Okay, now what I'm going to do is just press the X-axis plus once and it will move exactly, well, according to the DROs, it will move 600mm. So I'll take you back to the rule on the deck. So I'm just going to press it now and it should read exactly 600mm if the steps per are absolutely right. So here we go. What do you know? Listen, I'll just square the camera up. So that means moving it over slightly like this. Now I shall zoom into that. The other way. I hope there's enough light on that. And that is pretty well smack on. For a CNC, look, it's within 5 thou. It's absolutely fine for a CNC router. There's no need to be more accurate than that. So that is fine. Now I'm going to check the other axes as well, but it's exactly the same process. And I don't want to be boring, so I'll just carry out the same process for all the other axes. Okay, so I've just checked the other axes out and they're all running true and perfect. So now I'm going to get the router to register now all the axes in the home position. That's very easily done. You press this button here and then scroll down to return to home. You can either press OK or press that button down, and I'll just move the camera over so you can see it go home. Okay, here we go, returning home. Okay. I'm just going to swing you around to show you the controller. Let that one go home. Now if you look at the controller, you can see it's set on machine coordinates now. It's a different colour. Backing off and registered. Now how you move from machine coordinates to work coordinates and relative coordinates is just by this shift. Okay, so that's relative coordinates, shift again. Now that's work coordinates. Obviously that's the G54. So you know, you set this to wherever you want to start your work. So that's the 3 coordinate systems in it. And now we're going to measure the axes. So we're going to come out of that. So escape out of that. So we're going to start off with the X. So where I'm measuring from is here, which is the upright here. To here. I think that's the same height there. Yeah, there to there to get an exact measurement. And that is exactly 840 millimeters. So we'll write the exact figure down. So X equals 840. Just check that again. Yep, 840. Now the Z, obviously this can be slid up and down inside of the clamp mount there, but I want to measure the full extent, and we've got 220. So Z 220. I got that. That's 790. So now we will. I'm going to subtract a little bit because that is to the hard limits. So I'm going to extract about 5 millimeter or so off those figures, and then we're going to set the soft limits up. Okay, so now we need to choose machine and scroll to soft limits, and this is where we're going to put some information in. I suppose we could start off with this. No, we'll start off with the X, and it's in the plus direction. But first of all, we have to enable it, so that's going to be a 1, and the length is 840. 840.0. Enter. And the safe zone, I'm going to knock 10 millimeters off that. We're on the side of caution, so I'm going to put 830. Okay. And let me see, Y plus make that a 1. The Y plus length is 790. Okay, and we're going to say that, so we're going to say 780. Okay. Now let's come down to the Z. Now the Z length is in the minus direction, so the length is 220. And we're again I'm only going to take 5 millimeters off this, so we're going to say 215. Okay, and one more change we're going to make. Come over here to this one. Now it's machine mode. This is the machine coordinates, so that needs to be changed to a 0. Okay, and we need to save that and exit. So now we need to test it. Okay, so all the soft limits are switched on now, and all the figures are in correctly. Let's see if it works. So I'm going to keep my finger on that. Soft limits are on. Okay, so that is how simple and easy it is to set this controller up to be and the machine up together to be very accurate, or as accurate as you need to be with a CNC router. You know, you're mostly dealing with wood. You know, if you're cutting aluminium, maybe you need it to be within 2 thou, but that's about as accurate as you're going to get a CNC router. Which this is quite capable of machining those sort of tolerances. And we will, in the future, we'll machine some aluminium, this will do just fine. So I hope that answers a few of the queries that I've been seeing coming in with patrons and viewers and subscribers. So this is what you need to go through to get everything perfectly right and measure it, even get a DTI gauge on it if you want to. But like I say, the longer the distance you can measure, okay, the more accurate you're going to get it. And you just, you know, if you want to get it down to within 2 thou, first of all, you do what I've done just now, right? Done it on a long length 600. Then, if you wish to get it down to 2 thou, you can put a DTI gauge on here, okay, and move the measured amount. And if you find that it's a few thou out, 5 thou out, whatever, you just alter the motor steps just by one value. I mean, it's 300 I think it's 320. We'll alter it to 321 and redo the test and see whether you've improved it or made it worse. If you've made it worse, then you know that you have to alter it then to 321, and that's how you manage to get it right on the mark. you know, there's no grey. You don't have to work out how many steps the motor and calculate it all out. That's a load of baloney. You don't have to do it. You see what I just did? It's as easy as that. You don't have to. All you need to know, all you need to do is set your drivers, in my case, 1600 steps. You don't have to do that, but that's what I find works. 1600 steps, micro step in, and then set your SMC controller, like I did, 320, which is actually the manufacturer's setting, and it works fine. It's perfect with these screws. Okay, if you have different screws, this one particular one I think is, I'll tell you exactly. 5mm screw pitch. Alright? So 1 revolution of the pitch is going to move this head 5mm in one direction or the other, depending on which way you turn it. So that is roughly 5 complete turns is 1 inch. Alright? It's 25.4mm to 1 inch. So I'd say that's what this is. Okay, so there you go. It's 5mm pitch of the screw. Okay, this particular one. If it was a larger screw or a smaller screw, it'd probably be 4mm or 6 or 8mm pitch. Okay, so then the figures are going to be different in there. Okay, the larger the pitch, the smaller the amount of steps. Okay, the smaller the pitch, the larger amount of the steps. But then again, you can alter the steps in the driver as well. You know, you can go up to 3,000 steps, micro steps per revolution if you want to. You know, but the figures that I've shown you today, they work. Okay? So in answer to, I think, one patron's query where the Z did not come down to meet his work, it was, I think it was 3mm or something like that, off the material. I'd say go through this process first, measuring the length of travel for a given amount you put in. Okay, get that right and it should solve your problem. And there was also another query. I've had several queries with this, that Fusion 360, the hobby version, the free version, you can't write G-code tap, millimeters G-code tap. This is only metric. Okay, there is a patch out there for Imperial. I don't know anybody that's used it, so I can't tell you whether, you know, you would think that if it worked, there would be a lot of people on the net saying, oh yes, you know, convert this to Imperial, no problem. I haven't seen one person convert that to Imperial, so that would suggest to me that it doesn't. Metric. So, and the post processor that I use for that, and I have been using now for 2 years or more, because I've got a couple of these now, that is G-code millimeter tap. Okay, tap files. It's the really basic G-code. It's a step down from, if you see the list in Mark 3 millimeters, all right, there is a couple of things that you have to take out of the code for it to work in this. alright, without it being a bit jittery. But G-code millimeter tap, that's the only one that works in there, and unfortunately it's not available on the free version of Fusion 360. The paid version, I have both. I have the free version and I have the paid version. In my case it's a tutorial version, and in that version you can save in tap files, but the free version you cannot. It's not listed there at all. Maybe if Autodesk is watching this, I know they do watch a few of them, maybe you could you know, sort of alter your file system to allow the free version for hobbyists to be able to output G-code millimeter tap files for the SMC and others like it. Other than that, Cavco Maker, I use that one a lot. I have 3 versions because I make videos on behalf of Cavco, and you know, the best bang for buck on the market is Cavco Maker, and I will be using it in the next video with this. G-code tap files, use it all the time. The only other one that I know of course all the Cavco ones have it. The only other one I know of you can post-process through G-code millimeter tap is Aspire, and that's getting a little expensive. I mean, I like Aspire, it's fine, it's a good program, but you know, I think it's what, $2,500 US dollars now. That's getting up there a bit. Cavco Maker, best bang for your buck. G-code tap files, you know, certainly if you're on a budget, you know, and you want to use one of these, which I do recommend, and I have no association with SMC or the sellers at all. I buy my own, and you know, I do a lot of research into who's doing what, and I sort of did as much digging around as I could about these controllers a couple of years ago before I decided to, okay, it's worth taking the risk and getting one and seeing how it performs, which I did for the little small mill over there, and I've run 1 million lines of code through the one over there, and I've never ever had a problem. Never had a jittery code, never anything. Just, you know, put the code in, set the G54 and hit the button, off it goes. Never any problem. So I'm happy with them, and I personally, you know, speakers I find, I can recommend them, you know. I've used them a lot and no problem. And I actually find them easier than Mac 3, especially now. XP, Windows 7, you know, there's no support for it. So if you have a computer that crashes, and even though you might have, I mean, I've got XP disks here, but you know, you put another hard drive in, and of course you can use it for 30 days, I think, and then that's it. Got to have a key, and the key that's on the disk doesn't work. But there is There is a way around it, and I shall be making a video about that because I've got an old XP here that I've put a hard drive in, and I actually have made a couple of videos on my second channel about XP, but I've got I have discovered a real neat way of actually sort of having to, well, because you have to these days, of getting around the key. So in the next month or so I shall be doing a dedicated video for that, and it'll be on my second channel. And okay, so thank you for watching. Please like and subscribe, and if you would like to become a patron to the channel, because really the patrons run the show. You know, they're the ones that allow me to do this stuff here, because without them I wouldn't be making videos at all. So if you would like to become a patron, I would be very grateful. So thank you for joining me, and till the next video, which I think actually it has to be a laser video, because I have a new laser now which is sat over there. It's a 100 watt. It's a thunder laser. Best blooming laser on the market if you're looking for one. Okay, bye for now.